Good morning, good afternoon, good evening, good middle of the night to all of you. My name is Mr. Canfield, and today we begin part 2 of lesson 2-1, lines and stuff. So we're doing equations of lines using slope-intercept form. So if you remember from last time, we had this form, y is equal to mx plus b, where m was called slope and b was called our y-intercept. All right, so we've got this information. So what we're gonna do is, oh wait, I'm given a point and another point. I don't see the slope. So one way you could do this is you could go and put the points on a graph and try to find it and try to find the points. Remember, you need lattice points. These are gonna be 2 lattice points, but that might not do what we need it to do. So instead, there's another way, and that uses, there's an equation. If you remember we talked last time, oh, it's on my screen, how convenient. Slope, remember slope is the letter M, that's rise over run. So if we're talking rise over run, well, rise has to do with our y values. So in general, what we do is we're gonna take one y value and we're gonna take away the other y value, and that's gonna be the top. And on the bottom, we're gonna take one x value and we're gonna take away the other x value. But you can't just say y minus y, x minus x, because in algebra, when we use a letter, whenever we're looking at that letter in an equation, that letter always stands for the same thing. But we're talking about 2 different y's and 2 different x's. So what we do is we say, take y and put a little subscript 2, just like you would in water, right? A little subscript of 2. It means something different than it does over here. This means 2 hydrogen atoms. That's not what it means here. This means take the second y. This 2 doesn't, it's not squaring it, it's not an exponent, it doesn't do anything to the math. It's just saying take the second one minus the first one. And we do the same on the bottom. So if I'm doing this problem, well, -1 is an x, and so is 3. So we can call -1 x1, we can call 3 x2. -2 is a y and 4 is a y. We can call this y1 and we call this y2. So all I have to do, if I want to find the slope, and I'm going to find some number, and it just goes right there in the equation, right? So all we're going to do is use our slope formula, y2 minus y1. Okay, so y2 is 4 minus y1 is -2. So I'm doing 4 minus -2. If you struggle with stuff like this, just remember, you can use your calculator. You can literally go to your calculator. Let me see if this one works. It does, cool. Say 4 minus -2. It's fine. But we can also talk about it and talk about how it works too. So that's me at the top. The bottom, it says x2. Well, x2 is 3 minus x1 is -1. So 4 minus -2. So, so the top is 6 and the bottom 3 minus -1 is 4. The way we can talk about this though is we are subtracting a negative. We are removing a negative. And if we're talking about this like from money, if you take away -$2 from somebody, you're taking away $2 of debt. You're giving them money. So a double negative like this is always the same idea as plus. So 4 plus 2 is 6. Same on the bottom. A double negative is 4. Oh, 6 over 4. That is actually simplifiable. Simplifiable. That's the word. No, just kidding. We can simplify this. And the way that we would do that is in our calculator. If you don't know how to do this by hand, in your calculator, what you do is you use 6 divided by 4, and then you go to math. See how it says fraction? What it does is it takes what we got there and it converts it into a fraction. So let's talk about how to do it by hand real quick. So the way that it works, 6 and 4, well, is there anything I can divide both of them by and still wind up with a whole number? So I can divide them both by 2. If I do that, I get 3 over 2. And then I think, is there anything I can divide both of those by and still get a whole number? And in that case, no, I can't. So this would be completely simplified. So sure enough, that's the answer. So that's our slope. So now we know y is equal to 3 over 2x plus b, but we don't know b, right? So what we need to do is figure out what b is. And one way to do that is to plot one of these points. And remember, b is where it touches the y-axis. So I can just plot the point and then use the slope to follow back to the y-axis. But I want to do this completely without a graph. So what we do is you pick either one of these. So which one do you want to pick? Come on, tell me. Say it out loud. Why'd you say it out loud? I can't hear you. My math teacher's a jerk. Okay, so I look at these. I don't like plugging in negative numbers when I don't have to. I'm going to pick the 3 and the 4, but you could pick either one. So I'm going to plug in 3 for x and 4 for y. If we do that, this is supposed to be true. So 3 for x and 4 for y. Now, not b, 4 for y. We're trying to solve for b. So I've got 3 over 2 times 3. All right, 3 over 2 times 3, 4.5. Okay, so I get 4 is equal to 4.5 plus b. Well, how am I supposed to get b by itself? Oh, just subtract the 4.5 from both sides. So I get 4 minus 4.5. I get negative 0.5. Wait a minute, negative 0.5. Let me see if that's a fraction. Oh yeah, it's negative 1/2. So b is equal to negative 1/2. So my final answer, my equation of this line in slope-intercept form is going to be y is equal to, my slope was 3 over 2 x minus 1/2. All right. I almost asked if there were any questions, but I'm not trying to trick you again. Remember though, if you do run into questions, I would love to help you. Okay, so we're going to do the same thing all over again. Let's review the process that we did. So the first thing what we did was we find m by using y2 minus y1 over x2 minus x1. And remember, if there's any details in there that you like, that was kind of a light bulb moment, make sure you pause the video and write something down about it. You don't need to write complete sentences or anything, but the idea of writing, oh hey, like, remember the 2's and the 1's, it's just which one it is, doesn't do anything else. So we found m, then after we found m, we plugged m and one of the 2 points in to solve for b. So plug m and a point in to y equals mx plus b to solve for b. And then step 3 was write y equals mx plus b with m and b filled in. So here we go. First thing I'll do my slope formula. So 6 minus, or sorry, let's see, we got xy, so I'll call these 1's, call these 2's, right? Okay, so y2 minus y1, that's 6 minus 4. And then negative 1 minus 5. So if I do that, 6 minus 4 is 2, negative 1 minus 5 is negative 6. All right, and again, you can go to your calculator if you need to. 2 divided by negative 6. Math, enter, boom. So let's say you tried to do that. Let's say you tried to type this in and your calculator gave you an error. Sometimes people will do this and their calculator go, error, syntax. So what that means is we typed something in here the calculator didn't understand. If you, I was going quick, so you might not have caught it, but I actually did 2 divided by subtraction 6. And our calculators don't actually understand what dividing by subtraction means. So I have to do 2 divided by, I have to do 2 divided by the negative 6. So negative and subtract on our calculators, those are 2 different things and our calculator reads them different. So make sure you're careful and you use the one that you're trying to use. So anyway, negative 1/3. So that's our m. So I know m is equal to, oh, I didn't need to write that. Silly me, that's m, right? So I know y is equal to mx plus b. So I know that y is equal to negative 1/3 x plus b. And then I pick either one of these, and it doesn't matter. So I'll pick the 5 and the 4. So 5 goes in for x, negative 1/3 times 5 plus b. And the 4 goes in for y. So now when I do this, negative 1/3 times 5 is gross, right? But then I'm going to add it to both sides. So here's where I want to teach you how to use your calculator. So this is a fraction, right? So what we're going to have to do to this fraction to make it work, it's not okay for me to go, oh, that's negative 1.6. I mean, and you might be like, well, you didn't round it. Yeah, I know. So negative 1.6 repeating. There's a way to keep this stored in the calculator. And the way we do that is, well, if I'm solving this, I have to add that to both sides, right? So what I can do is I can say 4 plus, I can actually highlight that by pushing up, and it'll add to it, and then it keeps that, and I can handle it. So 7/3 is going to be my b. And if you need any more help with the calculator, you know, I'm all about helping you guys. So y is equal to negative 1/3 x plus 7/3. Okay, so a good chunk of our homework is just going through and trying these. So if you want, pause here, go try some of these homework problems, make sure they're working out for you. This process is really important for us to understand. I teach an AP math class that's the first year of college math, and we use this there. So this is something that's going to follow you all throughout the rest of high school, this idea and getting these things. So try a few of those problems, and then come back and finish the video after that. All right, so now we're going to move into looking at some word problems and talking about them. So these first couple of word problems do something kind of silly. You might remember we've been dealing with y equals mx plus b. Also, all of a sudden, we've got this weird looking thing, but it says this little f parentheses t thing. This is the same thing as saying y. So this is really just saying y is equal to 1.90 plus 1.4. And instead of saying t, that's really saying x. But that's just the first of the silliness. The second part of the silliness is we're used to seeing y equals mx plus b. We're used to seeing the x thingy come first, and this time the x thingy is second. So we want to be careful here. The slope is the one that's touching x. It's always the one that's touching x. So 1.9 is in our slope. It's not about the first one, it's about who it's with. So the 1.4 is our slope. What's a slope and what does it mean? 1.4. All right, now I haven't actually read the problem yet, so give me a minute and I'll go and I'll read and find out what it means. Y-intercept, that's our one that's by itself, right? 1.9. So this says the function below shows the cost of a hamburger with different numbers of toppings. Oh, okay. So if you think about this, we could have 0 toppings, 1 toppings, 2 toppings, et cetera, et cetera, et cetera. So we're going to say that the initial cost of the hamburger is going to be that number that doesn't happen over and over and over again. It just happens one time. So the 1.9, we can call this initial cost of hamburger. I used that word initial because we're going to talk about that a lot. Less fancy sounding words or like the flat rate or flat cost or starting cost. So now slope is something that happens over and over and over again. So 1.40 is our slope. This means we get charged this over and over and over. Basically what this is saying is this is the cost per topping. So if Jody paid $3.30 for a hamburger, how many toppings were on Jody's hamburger? Okay, so we could literally just set up an equation and solve it. So she pays $3.30. That's our y. That's like our final amount. So we could find this out. We could literally go through and solve it. I'm not gonna lie though, a question like this, I would go, oh, 330, okay, well, I know she paid 190 for the original, and then, oh, 1.4. So I know she paid 190, so I just subtract that away, and I know that she already paid that. So how much money is left? 1.4 is left. So she only got one topping. That's how I would actually do that myself. Instead of solving this. But to solve it, you subtract the 190 from both sides, then divide by 1.4, and you can find out what x is. The function below shows the cost to attend the fair if you ride R rides. So what's the y-intercept? Remember, the y-intercept is the naked one, it's the one without with the x with it. So in this case, it's going to be 5. Cost to attend the fair if you ride R rides. So this is how many rides you're riding and how much that's going to cost. So this is going to be the initial cost. And that word initial just means starting cost, right? The cost at the beginning. So price of entry. So initial cost. We could even say cost to get in. So what is the slope, and what does it mean? Well, the slope is the other number, right? 1.75 r. Oops, no. R is not the slope. So last time I didn't really talk about this, but the slope isn't x. The slope is the number in front of x. That's why I just said 1.40. This time I'm saying 1.75. And so what does this mean here? Well, all we need to do is, it's going to be, it's y over x. It's going to be y per x. And so the y's in this case is our cost. So you say cost per ride. If Al spent $19 at the fair, how many rides did Al ride? So again, the way that I might do this, I might go, well, I know $19 is how much $19 is how much he spent. There was the $5 entry fee. So now I just got to get to $14. So 1.75 plus 1. There's 2 rides, 3 rides, 4 rides, 5 rides, 6 rides, 7 rides, 8 rides, 8 rides. So you might want to do it that way instead of going, oh, okay, I know we spent $19 total. And now I'm just trying, so I'll subtract 5 from both sides and get $14. And then I'll divide both sides by 1.75. So $14 divided by 1.75, 8. Wow, I got the same answer. So I'm not going to tell you that you have to use, using a bunch of symbols, we will call it symbolic algebra. I'm not going to say you have to do that. I think that in this case, this was faster than me going through and figuring it out. But if you figure it out, you figure it out. Okay. Let's see what's next. Good, lots of word problems. Lots and lots of word problems for us to have to talk about. We need to talk about more word problems. The function below shows the cost for Mrs. Franklin to go to a buffet with C of her grandchildren. What's the y-intercept and what does it mean? So again, the y-intercept is the one that doesn't have any numbers with it. So the y-intercept is 685. What's it mean? Well, let's see. C of her grandchildren. Well, that's saying that there's going to be Mrs. Franklin and then however many grandchildren. She could go by herself with 0 grandchildren, or she could go with 100 grandchildren. So this 685 is Mrs. Franklin alone. What is the slope and what does it mean? Again, that's the number with the x, or in this case with the c. So the slope in this case is the, so if that's the cost for Mrs. Franklin, this is going to be the cost for each kid that comes, right? So this is the cost per grandchild. child. So Mrs. Franklin paid $18.65 for the buffet. That's when she was born. No, just kidding. How many of her grandchildren does she take to the buffet? So again, we could just say, well, I know if she pays $18.65, well, she paid $6.85 for herself. So she paid $11.80 for the rest of them. Well, how many grandchildren is that? That's the first one. That's the second one. That's the third one. So four grandkids. Yeah, we can totally figure it out like that. Or we can say 1865, the year she was born, just kidding, is equal to 685 plus 2.95. C. Subtract the 685 from both sides. Get 2.95. C is equal to, I forget what I got when I did that a minute ago. $11.80. And then we do that divided by 2.95 and get 4. All right. All right. The graph below shows the number of newspapers delivered and total pay for Leona's newspaper delivery job. What does the slope of this graph represent? All right, so it's asking for the slope of this graph. Really easy way to talk about slope on a graph. You can write the word that goes with y per the word that goes with x. So let's find the slope first. So the first thing I need to do is find some lattice points. Remember, places on the grid, crossings on the grid. So I found here and I found here. So looks like 0, 0, and 20, comma 5. You might say, oh, it rises 1 and it runs 4, but it doesn't rise 1 and it runs 4. Look at the scale here. It's going by 5s. It actually rises 5. See that? One box is 5. How far does it run? 5, 10, 15, 20. It actually runs 20, 5 over 20. So in this case, 5 over 20 does simplify, and it turns out to be 1/4. But anytime we have different numbers on our scales, be careful about the numbers that we write there. So 1y per 4x. All right, what's the y? Dollars. So we can say it's $1 per I wrote that wrong. So, I mean, it is $1 per 4 newspapers, but we usually write the slope as 1. We say $1/4 per newspaper. Wait, $1/4? That's a silly way to say that. We could say 25 cents per newspaper. Dion pays a fixed fee plus an hourly rate to rent a boat. The table below shows how much Dion paid for the boat. What was Dion's hourly rate to rent the boat? Hourly rate. That's another way. Whenever you see that word rate, it's generally asking slope a lot of the time. It's possible it could be different. Sometimes they talk about a flat rate, which means it's not a rate at all. It's just that's how much you have to pay one time. But let's see. So an easy way to figure out hourly rate is to figure out the change per hour, right? Well, this is going by single hours. So how much does it change from here to here, then from here to here, then from here to here, then from here to here? Is that the same for each hour? 27 to 39. We could do 39 minus 27 if you can't figure out what it is. A lot of people will just look at that and know that it's 12. And that's fine, but you could do 39 minus 27. You could do 63 minus 51. But you could even do something silly, like you go, oh, 75 and 51. If I do 75 minus 51, I get a different number, but that's because it was from 3 to 5. So I would divide that by the 2 hours that was. So 12, all you have to do, y per x. Y is amount paid. So $12 paid. Y per x. $12 per hours. Slope is always going to be y per x. Okay. So I'll finish up these 4, and then the rest is up to you. So, yep, that'll be good. Write a linear equation in slope-intercept form to model each situation. $2 per hour. Ooh, that's a slope. So I can write 2x. So I got a little bit ahead of myself. Y is equal to 2x. Let's see. $20 plus. So that's how I would write it, 2x plus 20. An auto repair shop charges $50 plus $25 per hour. So I could write this as, yeah, I could have written it the other way around. I could have written 20 plus 2x. That would have been fine. Like on this one, I could say, well, it's a $50 flat rate plus the $25 per hour. A candle is 6 inches tall and burns at a rate of 1/2 inch per hour. So in this one, I could say, well, it starts out at 6 inches, so we could say plus 6 on the end, or we could have the 6 at the beginning. It doesn't matter. It just doesn't go with the x. And then it burns at a rate of 1/2 inch per hour. So does a candle get longer as it burns? No, it shrinks. And so because of that, instead of saying we add 1/2 every hour, we actually subtract. We have a negative 1/2 that we're getting every hour. The temperature is 15 degrees and is expected to fall 2 degrees each hour during the night. So again, we could say we start out with 15 degrees and we're going to fall 2 every hour. So I had some people asking questions, getting stuck on these from the homework because there were no lattice points. So I'm going to do I'll do these 2 and then I'll cut the video there. So let's see, slope-intercept form. So we need y is equal to mx plus b, right? So first thing, we want to find our starting point, our y-intercept. So there it is at 1, 2, 3, 4 negative. So minus 4 right there. And now I just need to figure out the number that goes in front of x. And so I have this lattice point. I'm looking for another place where it crosses on the grid. I see one there, and I see one there. So it doesn't matter which one of those you pick, actually. So if I go 1, 2, and then 1, 2, 3, I went up 2 and over 3 to get to that next lattice point. So my slope is 2/3. If you had done this one over here, 1, 2, 3, 4. Wait, that's a different number. 1, 2, 3, 4, 5, 6, 6. Wait, but what's 4 over 6? All right. Lastly, but not leastly. So remember, we want to find our starting point first. There it is. Plus 2. Now let's find our slope. I need another lattice point to do it. There's one, there's one. Cool. Looks like there's one. So I'm gonna go, I see this one. I went down 1 and then 1, 2, 3. So down 1 I'd call -1, and then to the right 3 I'd call 3. So we'd say -1/3 x plus 2. You could also go up 1, that's a +1, and then 1, 2, 3, and then we went left, so 1 over -3. You can say -1 over 3, 1 over -3, they're the same thing. Our first homework question actually goes along with that, that you can do either one. And as long as you just pick one of them to be negative, it'll work out. So, cool. 28 and 29 cover I got time. All right. Wait, flatline. What? So I got an easy way to remember this. It's all about skiing. Put a skier on here. How much fun is this skier having? They're having no fun, right? This is a slope of 0. If we were to count the rise over run from one point to another point, we wind up getting a rise of 0 and a run of, well, in this case, 2. And 0 divided by 2 is 0. So with an equation like this, we have y is equal to 0x. What's our y value? 1, 2, 3. Flat lines we actually write as y equals that number. And to talk about this conceptually in another way is, what point is this? Well, this is the point 0, 3. This is the point 1, 3. This is the point 2, 3. This is the point 3, 3, 4, 3, 5, 3, 6, 3, negative 1, 3, negative 2, 3. The y value is 3 for every one of these points. And so that's why it says y equals 3. If you look at these, what do all these have in common? All these have the x is negative 2. Negative 2, 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 negative 2. Guess what? It's x equals negative 2. What kind of slope is this? Well, if we try to draw the skier on this one, I think we might have to draw the skier like this. There's this little hat falling off. Here's the spikes at the bottom. So the slope of this we actually call undefined. Another way of saying there isn't one. You can't ski on this. It's impossible. You die. So flat lines have a slope of 0 because there's 0 fun. Vertical lines have a slope of undefined because you will be undefined if you try to ski on them. And for a lot of people, sorry for my chair making loud noises. For a lot of people, y equals 3, x equals negative 2. The y and the x, they're numbers that are, the letter is kind of the opposite letter of what they want it to be. They want this to be x equals and they want these to be y equals. I was like that for a long time, and if you are like that, just remember, oh yeah, my gut on this is like the opposite of what it's supposed to be, and then you get in there, well, I want this to be x equals, oh right, but my gut's wrong, so it's y equals. Like, that's perfectly fine. That's a perfectly good way to think about this. Okay, graph a line that passes through the given point and has the given slope. So all I gotta do is go to that point, 3, 1. Remember, points go x, y. So 1, 2, 3 on the x and 1 for the y. So start at that point. Slope of 2, 1, 2. Oh yeah, sorry. Anytime you just have a plain number, it's over 1. So I go 1, 2 over 1. And you can always reverse it, right? Down 2, backwards 1. That also works. But now we have this line. And if you want, down 2, backwards 1, down 2, backwards 1, you could even find the equation for this now that we know the slope and we tracked back to the y-intercept. You could even do that. But that's not what this question is asking me for, so I'm not gonna write that. So on this one, we start at negative 2, 5. So negative 2 is our x. 1, 2, 3, 4, 5 is our y. Slope is negative 1/3, so go down 1 over 3, down 1 over 3. And you could do it again. Down 1 over 3. Woo! Let's see. Ooh, a slope of 0 in our next one. Remember, 0 slopes are 0 fun. And undefined slopes make you hard to find because you fall into the abyss. So go to the point 4, -2. 1, 2, 3, 4, -2, dot, and then draw an unfun slope of 0. Whee! And then 3, -2. We'll go 1, 2, 3, 1, 2, bop. Slope undefined. The spikes are not necessary. You don't need to draw the skier and the spikes or the skier not having any fun. But there you go. Cool. Ladies and gentlemen, I hope this has been helpful. There is a homework assignment on Savas for you. Until next time, everybody. Bye.